Mehdi Benna, and this is a real-size model of the Lunar Environment Monitoring Station for the Artemis III mission. I would like to start by citing two quotations that defined lunar exploration of the 1970s. The first, very famous, was uttered by Neil Armstrong, the commander of the Apollo 11, when he first set foot on the lunar surface. This statement defined the subsequent 3 years of lunar exploration with the 6 Apollo landings. The second, less famous, was spoken by Gene Cernan, the commander of Apollo 17, while leaving the lunar surface to return to Earth. This less famous statement defined the subsequent 50 years of lunar exploration by declaring the end of human presence on the moon. So for the last 50 years of space exploration, and despite all human achievement in space, lunar exploration with astronauts was relegated to the feat of a single generation. Few small steps that humanity chose to not continue. Enter recently. In 2004, NASA announced the Artemis program, which set itself the goal of returning astronauts to the moon for scientific discovery, technology advancement, and to learn how to live and work on another world. The Artemis program will see that the Artemis III crew lands on the surface of the moon by late 2026. But unlike Apollo, this new program will progressively bring along all the elements needed to build permanent stations in lunar orbit and on the surface of the moon. So mankind is going back to the moon to stay, and to stay in a very special location, the South Pole of the moon. So the lunar South Pole is one of the most mysterious, least characterized environment of the solar system. It contains permanently shadow craters, areas that have not seen the light of sun for billions of years. Regions so cold, they still hold on ice deposits that date from the early formation of the Moon-Earth system. And so to explore this new frontier, NASA selected 3 instruments to be carried and deployed by the crew of the Artemis III mission on their historic maiden voyage. One of these instruments is the Lunar Environment Monitoring Station, or LEMS. And so LEMS is a compact instrument that will monitor the seismic activity at the South Pole for several years. The system is autonomous. It self-manages its power production, its data collection, and communication with Earth. To collect seismic data, it carries 2 optical interferometry seismometers with a wide seismic frequency band. LEMS is led by UMBC with collaboration from NASA Goddard Space Flight Center, the University of Maryland, College Park, the University of Arizona, the University of Washington at St. Louis, and Morehead State University. So you may ask, why a seismic instrument? Well, it happens that the moon is very chatty in the seismic spectrum. If you can only listen to the moon's ground noise, you will hear a lot of rumbling. You will hear the signatures of shallow quakes that are triggered by faults and scarps on the crust. Deep quakes that are caused by the tidal deformation of the entire moon. Thermal quakes that are generated as the surface transitions between days and nights. Impact quakes that are caused by the constant infall of micrometeoroid onto the moon. And so by listening to all the signatures of these moonquakes, we can reconstruct the composition and the structure of the lunar interior. We do it in the same way we can reconstruct the image of the human body with ultrasounds or X-rays. And so the LEMS you see here is a full-up standalone spacecraft. It has solar arrays to produce power when the sun is up. It has batteries inside to generate energy at night. It has a thermal system that keeps it from overheating during the day and keep it from freezing by the minus 200 degrees centigrades of the lunar nights. It also has a telecommunication systems that allows us to link to it once a month so we can retrieve the seismic data. On the side here, you can see a box where the 2 seismometers are stowed until LEMS is delivered to the moon. Once on the surface, the astronauts will extract these 2 seismometers and will bury them in the ground a few feet away. So, as we embark on this new journey of exploration, I would like you to remember that LEMS is the result of several years of research and development by 36 scientists, engineers, managers, and support staff. Years spent designing and testing every technical aspect that made LEMS possible. So, as I'm privileged today to address you, I'm only the representative of these outstanding individuals from UMBC and all the partner institutions who are making the Lunar Environment Monitoring Station possible. So, to end, I would like to take the opportunity of this event to reveal the new visual identity of the LEMS mission, its mission patch, and its logo. Thank you for listening.